Hi, how is everyone? Okay, so, yes, thank you all for coming and surviving lunch. I mean, I feel like once you're at a conference, if you can get past lunch, you're doing good, right? So, welcome, you've made it. So, you may know the title of this talk is called Making Web Apps Lightning Fast. At Microsoft. The web is actually kind of new to us. Traditionally, we've done a lot of things in .NET. Is anybody else here work at Microsoft here present? No? Okay, just checking. But, well, no. Haha, I can say whatever I want now. No. That's true. Okay, so, but it is new to us, right? JavaScript wasn't our first love or language. You saw that we tried to solve a need with TypeScript to be able to make it more scalable and manageable, right? So this is still kind of new to us. But anyways, I digress. So my name is Sean Larkin. I am a program manager for Microsoft, working on Microsoft Edge. I'm on what's called the developer experience team. And our subgroup is called ecosystem. So what I do there is I work with frameworks, tools, high-profile open source projects, Webpack, Rollup, Svelte, React, Vue, and we partner with them to say, hey, how can we make the web platform better? You may have just recently heard that we decided to build a third iteration of Microsoft Edge, the browser. And who's running a PC today? Who runs PC? Who does their dev work on a PC? Right, okay, so today you can go and install it at MicrosoftEdgeInsiders.com. But now that we've closed the gap for interop and features, all we want to do is spend our effort on developer-facing features. But you may know me as somebody who is one of the maintainers of the Webpack open source project. Who uses Webpack here? Okay, wow. I also spent some time on the Angular CLI team. I helped bring Webpack to the Angular ecosystem. And yeah, I met Gerard at the first NG-Con, yeah, that was a long time ago. But I'm also representative for the Node Foundation, or what's now the OpenJS Foundation. And I also help represent Microsoft at the WebAssembly community group. So I hear Jay all the time rambling about WebAssembly. A little bit about myself, though, is that I'm a former tech support rep gone rogue. I actually have a music degree, but I got so tired during my job of not being able to actually help people, I taught myself how to program, and I started with Ruby and Objective-C, and then finally fell in love with JavaScript. And you can find me at any of these places online, so if you don't follow me on Twitter, I tweet a lot, so it's a lot about Webpack, so if you don't like that, don't follow me. But you can reach out to me at any of these places, and I'm pretty receptive. And then finally, I want to give a call out to, do you know what Trivago is? Right, so they're our #1 sponsor for the Webpack open source project. But it's not just them, it's all of these companies that are listed here. And without their support, I don't think we would be able to deliver things like Webpack 3, Webpack 4, or continue the progress and being what we want to be, the LLVM of the web ecosystem. So let's give those people a round of applause, please. Thank you. All right, so let's cut to the chase. We just had lunch. We got to keep this high energy. Web performance. So there's it's kind of a buzzword. There's a lot of different ways that you could describe web performance. Some people focus on, using request animation frame to avoid scroll jank, or, is this rendering at 60 frames per second, right? But that's not what I'm going to talk about today. What I'm going to talk about today is specifically about interactivity. So who here has to care how fast your page loads? Right? Okay, who does an e-commerce platform? Who relies on ads and search, like in a newspaper? Right. This is one of the most important metrics for you. Who builds critical doctors software in hospitals, and a good example is we had somebody who we have a partner who makes web applications for hospitals, and they said, why do I care about performance? Well, you don't want your patient sitting there while your doctor's waiting for a page to load, right? On their iPad or whatever. So, but interactivity, what does it mean? because I'm going to use this a lot. So you load a web page, and it's how fast that you can actually tap or interact with the page. So sure, you might server render a majority of the first view, but if you can't interact with it, it's useless. So this is what interactivity is. And I thank Adi Asmani for this, who posted this in an article. And this is controlled by the resources that you send down on your initial page load. So you might hear this kind of web performance called page speed time, page load time, time to interactivity, and that's all what we're going to be talking about today. So when you profile a web application, let's say you're using the new Microsoft Edge DevTools or the Chrome DevTools, right? It's the same underlying core. You can do a profile, and you can see here what are the most expensive resources that are taking up the time until this interactivity. And you can see here the yellow bar, it's basically plastered with yellow, and that's JavaScript. So what I want you to think about, or if you're going to jot notes at any time, here's the time to do it. What are the top 3 most expensive resources when it comes to loading an application? So the first is the amount of JavaScript for your initial download, right? So how much JavaScript have you forced your HTML page to go request and parse, evaluate, and execute? Then secondly, the amount of CSS total for your initial download that your page has to parse, evaluate, and run through what we call the formatter engine. And then last but not least, but kind of a distant third, is the amount of network requests for the initial download. So you might say, like, okay, Sean, well, what's an acceptable amount? Now, I don't want anybody to fall back, or these are really small numbers. And there's a lot of context here, right? Like, if your main customer is in a 2G network or e-commerce and page speed is the most important thing for you, and they're on flaky networks or devices, then this is critical then. So the first thing for JavaScript is 200 kilobytes, uncompressed. Now you're going to see me say uncompressed a lot because compressing an application doesn't solve the parse, evaluation, and execute cost. It's just a network enhancement. So let's say when I'm looking out for JavaScript libraries and I see somebody say, the new micro date functions, 1 KB. I'm like, what's the uncompressed size? It's 44 kilobytes. That's what your browser actually pays for when you use that application or that library. So uncompressed is really important to measure. And then finally for HTTP, depending on your protocol, if you're using H1, it's around 6 requests. And then for H2, it also varies, right? Because there's different flavors and different servers that implement it. I say anywhere between 20 and 50. And then finally, there's a statistic that I haven't added yet, or talked about on the first resource, but it's going to be probably the most important thing that you walk away with, which is called code coverage. So now, when I talk about code coverage here, I'm not saying Istanbul or seeing how well your code is tested. Instead, I'm talking about how much of the code on your application actually gets used on the initial download. So how can we test this? And I'm just going to break out of the presentation. I'm going to show you right now in a Microsoft product. So if I open up the DevTools, and if I type Command-Shift-P and I type coverage, you're going to see an option that says show coverage. So this panel, I don't know why they make it so hard to use. Maybe other browsers will make this better someday. You can go ahead and, so you hit the reload icon. Let's see how well it loads on Wi-Fi. We'll see if it works. If not, we'll have photos. Maybe not, if that's okay. That doesn't matter. No, typically it's just frozen. We can try it again. Okay, we'll jump back to it. I have screenshots, that's okay. So what this does is it actually loads a table that tells you for each resource that you shipped, how much of it was used and how much of it is unused. And so I urge you to go and try this, run the measurement, hit the reload icon. Maybe I'm just going to give it one more try. Let's try it. It's okay if it doesn't. Okay, we'll just use this since I know it's readily available. Okay, coverage, hit record, there we go. And you get a list of the assets, right? And a summary like 2.2 out of 3.1 is unused on this application. And that's not that great. That's a lot of JavaScript. The problem here, why is this important? Because only what? Like 28% of the JavaScript here is actually needed to render the page, but you're paying the cost of everything that is loaded on this initial download, right? And these are the most expensive resources. So keep thinking about that. So what can we do? We would need to take out the code that's not needed and isolate it and only load it on demand, right? Lazy load it. Luckily, there is a solution. There is a feature that exists that you all have access to. It requires zero configuration, and it's called code splitting. Who here uses code splitting today? Oh, good job. Nice. Okay. For this talk, I wanted to figure out, like, how could I define what code splitting is? Because it's kind of a term that gets thrown around, and it's not very, like, in a way that isn't accurate. So I tried to do some soul searching, right? And then I found it was like the top hit was Webpack, and I was like, dang it! I need to give something before that. Who has ever used this framework? Google Web Toolkit? All right. So these are the pioneers of code splitting. So if you look at this example here, gwt.run async is a function that was added to the API. And what this does is it says anything inside of these brackets or parameters is going to be compiled into a separate JavaScript file. The whole thing about GWT is that it let you write Java and compiled the JavaScript. What could go wrong? There's nothing wrong here. But the main point is that it's going to create two files instead of one, right? You're going to have the initial JavaScript, and then it's going to separate the code not needed up front, and it's going to compile that into a different file that'll only be loaded on demand. So then came around Webpack, and I want to give you a story, and I'm okay with breaking out of the presentation again because it really just requires you to go to our GitHub page. So Webpack was actually created as a side effect of a master's thesis by a gentleman by the name of Tobias Koppers. And at the bottom of our it's a really big README, and because we all our sponsors, but we have a special section here, right, that says thanks to. And so the first is for Google Web Toolkit, because we decided there was no bundler out there that had this feature called code splitting. So thanks to them. And then finally, Medicu, which says for Modules WebMake. So Modules WebMake is a similar project, and Webpack was born because I, Tobias, wanted code splitting for Modules WebMake. So you can actually navigate to the GitHub issue, and it's still open to this day. But you can see here that we suggested, hey, we want to be able to add this code splitting feature. It doesn't exist today. And the author was like, oh, I don't know. I mean, you don't want to mess with these semantics, and maybe it's not the best idea. And then Tobias, going further, said, no, it's definitely possible, and I'm happy to make a contribution. And so he said, okay, I re-implemented the entire project except implementing code splitting. I love this story. And Medicu's like, oh, wow, this is interesting. But I don't know if we really want to go forward with this. Thanks. If you change it, just, change the name of the project and don't just use the fork. And he said, okay, thanks. And he said, okay, I moved the project to Webpack/Webpack. In 2012, mind you. This is 2012. Okay? And, obviously the issue, I think, got closed, but then it got reopened, and then, you can now see people, when Webpack got popular, it was 2016. Pete Hunt at OSCON West debuted it about how Instagram uses and bundles their application, and then Dan Abramoff, shortly after at React Europe, showcased hot module replacement, and, it exploded. So you can see here, we even have people in 2016 oh, that's how it happened, right? They started reading our repo and the README. So Along came Webpack, and we decided to implement code splitting. So, what is code splitting, I guess? I tried to come up with a concrete example, and the best way we could describe it is the process of splitting pieces of your application into separate bundles or chunks at build time. At build time. That is super important, is that this is all done at build time. So how does it work, right? So there's two types of code splitting in Webpack, and really, I think it's just helps you understand when you should use them. So one is called static, and the other one's called dynamic. Now there's huge quotes around this because nothing in Webpack is dynamic. It's a static build tool. Everything that it produces at build time, and there's no runtime capabilities, which is a designed feature. So when would we want to use static code splitting? So heavy JavaScript. Anything temporal. So like if something doesn't exist on the initial render of your page, code split it. Or I extrapolate on this and say, well, who has a client-side router in their application? How many routes does a user visit when they're on a page? One. So you don't need any of the other routes until the user goes to that page. So I have an example here, and it's pseudocode, but I think it gets the idea across. And we'll go over some more, in a bit. But so we've imported a listener, right? And that's a static import, right? We need this code up front. We are going to listen to some user behavior and trigger an event, right? And then the next line here, we have get modal. And it's a function that returns a dynamic import statement. Who is familiar with the dynamic import statement? So this is a new JavaScript syntax that is standard in all browsers. I think, yeah, it's all browsers as of now, except IE 11. And what this allows you to do is, as a browser feature, dynamically fetches any piece of JavaScript and executes it. So that's really great. What we decided to do with Webpack is we said, well, let's adopt this syntax as the signal for when we should separate this code into a different file, right? So that way, if someday Webpack's not relevant, rip it out and your code's still valid, right? So now let's go back to the implementation. Listener.on, and the event, it's so cleverly named, did something to warrant a modal being clicked. Okay, we know what's going to happen here. So now we're going to actually, only until this event is triggered, are we going to call this function, right? And what happens is that Webpack will take and convert this dynamic import statement into a promise that returns a module after it's been JSON P fetched. But the important part that you want to know is that the module itself is going to be available once you unwrap the promise. We handle the implementation details. So you can see here we call .then, we get the module, and then we perform the functionality. This is the art of code splitting. We didn't need to statically import get modal up front, right? Because we don't even know if the user is going to trigger this event. So why load the code up front if you don't need it? Especially knowing that JavaScript is the most resource intensive, costly, when it comes to page load and initial interactivity. So what happens? Like I said, here is a dependency graph, right? Let's just say it's just these three modules in your application. App.js is your entry point. We statically imported the listener, and we code split, or we use the dynamic import for the modal, or get modal. So the result is that Webpack creates a boundary between these two, and it says, okay, well, let's split this up into two files. One is going to be the initial bundle, and then a separate JavaScript file for just that functionality. Well, let's say if there was another dependency inside of that modal code, that would also be separated into that lazy loaded file. Okay, so dynamic code splitting. Nothing is dynamic in Webpack, so it's dynamic. So here's an example. Let's say we wanted to, based on some runtime value, asynchronously load something. A perfect scenario for this is dashboards, widget systems, like little Wix, like have a user be able to create their own content or website, right? We can say, or like theming. So here we have a function that says get theme. So what we know is going to happen is that it takes an argument called the name of the theme. And what we do here is we have the dynamic import statement again. But there's actually an expression inside the path. And this is important, right? So the user implementation here, though, is that based on what kind of runtime condition, like a window variable, we can apply a different theme, at runtime. So this way, we just loaded an async bundle based on a runtime condition. So something that isn't static. That's why we call it dynamic. Now you could, right. And so when I saw this, I was like, what? What? Completely over my head. I had no idea what was going on. So let's break it down. So if we break it down, we just look at the function, right? Get theme, it's equal to a function that returns a dynamic import, but it has an expression inside. And so I kind of separate these two things. Like we have the partial path, right, which is a part of the expression. And then we have the actual variable, which gets interpolated. You can think of it as that partial path as a directory that is resolvable that has modules inside of it. Now, what we call it in Webpack is a context module, but naming things is hard, right? We should have called it like a directory module or something like that. But the important part is what it does. So let's say you have in your source code, you have a themes folder with all these available modules, right? So what we're doing is we're saying, hey Webpack, find me all the possible modules in this partial path and create individual lazy loaded bundles out of them. Now, only when that function is called, fetch the module that pertains to the name that's called, right? So if I called get theme and passed in the string hipster, it's going to return 0.chunk.js. And this all happens for you automatically. Webpack handles that. So when do you use it? A/B testing is great, right? How many people A/B test on the client side? Okay, do you include both tests in your JavaScript bundles? Maybe, I don't know. But this is a great example where you could only load a test if it's actually needed or used for that user. Theming, we all do, theming is super popular. Design systems, this is super critical for that. But mostly this is about convenience, right? Because I could go back here and I could implement this using static imports, right? I could say if, window.feeling.stylish, and then I could say static, like I'll use the dynamic import .then, and then, pull out the data. But this is a really nice convenience pattern, right? It beats having to have giant switch statements or giant if-then clauses when you're conditionally trying to load something lazily. Yeah, I know, the WAT meme is so good. So you might say like, all right, Sean, whatever. What does this look like in the real world? And I did say that this talk was called Web Performance at Microsoft, or how we make our apps lightning fast at Microsoft. So one of the amazing things, and I'm so grateful for, is that I get to work with teams across the company and help them improve web performance and triage their build architectures and their build systems. So I started this as a way for me to not only prove I'm doing stuff, right? I have this internal blog, and they're based off of Word documents and reports that I write up. We're big on reports at Microsoft. And it's a way for us to scale knowledge, to other people without having, to overdo your individual impact. So this web performance journal is literally just we have these case studies, or what we call performance clubs. So I go and meet with a product team, and I say, hey, what kind of performance issues are you having? They say, we want to speed up our load times. We notice that this is an issue. Here's our architecture. And then we do a diagnosis of it. And so the application that we're actually, I'm going to share with you, with their permission, of course, is called config.office.com. And you may have noticed that that was the page I loaded, right? So we'll see this. So what is config.office.com? So you can read this really long sentence. I don't recommend it. But this is their official, what is it? But long story short, this is a web application which allows some sort of system administrator, deployment administrator, third-party deployment products and teams. They allow to have a custom executable and create a custom executable with whatever products they want of Office 365, and then deploy it en masse, right? So this allows them to do that through Azure services or just standalone. And so this is super critical for enterprise companies and small businesses alike, or management companies for these products. So, but for everything, you need a methodology, right? For performance, and I want to talk about it.
Measure, you profile, diagnose. It's like MIPDIA.
It's like MIPDIA?
MIPDIA.
It's what MIPDIA?
MIPDIA. You measure, you profile, you diagnose, you identify, and you attempt.
Oh, you're making an acronym about
MIPDIA. 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 It's the new framework for performance diagnosis. There was Rail, and that was cool, but that's so like 2015.
Sure.
MIPDIA is so 2016.
Yeah, totally.
Right? Like you just hear MIPDIA, MIPDIA.
No.
Like people are shouting it, I hear it. Really?
Right. So this is Sam Ciccone and Paul Irish. If you don't know them, they're great follows on Twitter, and two people I really look up to a lot. Now, this was really like a joke, right? This whole MIPDIA, but I take it seriously, right? So this is the process that we use to identify and profile these applications, right? And you have to have a system, right? So that you can go and repeat these steps. It's consistent and allows you to really kind of, as Andre Stoltz says, like to have a clear train or clear map of thinking, right? So the reason that they even reached out, so I'm going to call them the OXO manageability team or config.office.com, they reached out to us because they wanted to be able to, one, upgrade to Webpack 4. But they also noticed that they were having issues with Webpack or with just web performance and load times. And so the first thing that we did is we measured, right? And here, let me actually make this full screen again, sorry. There we go. So the first thing that we did was we actually measure. And so how do we do this? So we do this by going into the Performance tab in your DevTools, and we see how long it takes for the page to become interactive. There are timing events that actually trigger and fire, and so we can use that to measure and identify. And so the first things that we noticed were like, okay, if we load this page on a broadband network, it takes 4 milliseconds. 4 seconds to get interactive. So I'd have to sit on my computer and wait 4 seconds, like my dev machine, so like a fast computer with good Microsoft broadband to be able to access this page, right? So that was really suspect to me right away. But then 3G low-end devices are a consumer to us, right? Think if like I'm on call and I'm using the company phone, which may not have the best Wi-Fi, or I'm like on a subway or in an airplane is a good example, which we had a customer who had this issue, couldn't access this page because it took 20 seconds to load. 20 seconds and 21 to get interactive. So we kind of dug deeper, right? So like we're at the measure part, and we're trying to now profile what the primary cost is. So we use the coverage tool. This is my first tool that I will use over anything because I know JavaScript's the most expensive resource, and 60% of the JavaScript and CSS that the whole world submits goes unused, right? So that's the most lowest hanging fruit that we can try and tackle. So I do a code coverage report here, and although you can't see the actual numbers, I have it down here in a chart. So the total amount that was unused was 18.2 megabytes. That's a huge amount of JavaScript, right? And out of a total of 18.8. So the waste percentage was 97%, right? We make the same mistakes too. We're not exceptional. And that's what I think is cool though, because we use the same technologies as you do. And so you can solve it in the same way that we solved it. So what's great is that if you click on one of the line items in the coverage tool, it actually shows you a line per line representation of like what was unused and what was not. And so we wanted to dig deeper into this giant 16.2 meg JavaScript file and say, what is going on? Like, what is in this file? So we looked and we saw locales. So who has to support internationalization, right? Like that's a pretty hard requirement for a lot of people. So, right, yeah. Can you relate, Switzerland? You have like what, 6 languages here? Okay, yeah. So, but obviously, you don't need any of them up front except for like what default, right? Maybe? I don't know what your requirements are, but for the initial page load, the user's probably only going to have one. So this was a huge red flag to me, right? All of the 16 megs here were just strings of object data that were localization. And you can see that here. Like, it immediately was a red flag when I saw all of this Japanese in here. I was like, what is going on? So here is an excerpt from the exact code in the code base. So you can see here that we're actually statically importing every single one of the JSON objects of the localization strings, right? It's exactly what we saw in the code. And then we did that 200 more times for every locale, region, and product because we have a lot to support at Microsoft. And then at the bottom of this file is a switch statement that said, okay, get app settings for locale. And so it like defines a bunch of variables. And then it says, well, if that locale is DE, assign them all to a variable and return those strings, right? So what's the problem here? So now if this was something that needed to be done up front and you needed every locale available, I would get it. But I dug in deeper and we found, okay, so go look at the file that uses that class and go look at the React component that uses that class, which uses that file, right? And we found that it was, it's called application settings container.v2, right? But it was inside of this component that has a default state, default visibility of off. So it's not even visible by default. So this is like a huge win for us. We don't need any of these locales until they open this freaking dropdown, right? So awesome. So we now can kind of diagnose what the unoptimized behavior is. It's the JavaScript, right? There's 16 megs of JavaScript. It's the primary cost resource. And even though we're only using 3% of it, the browser has to pay for all 17 or 18. So we now know that there could be a solution that maybe we can start leveraging like some lazy loading pattern. So what's the root cause though? So this document is a report that goes to CVPs, VPs, like lots of people. And so not everybody understands what the heck Webpack is. But this isn't really like redacted, like you can view this. I just wanted to summarize the important piece here, is that this build system is Webpack. They use Webpack, and it's the second most used JavaScript open source project across Microsoft. So this is something that people can leverage, this technique that we're going to show you. So what's the root cause? It's bundlers. People statically import the code, and it gets put into the initial bundle. What, Sean, how can you say that? Okay, so maybe it's not really bundlers, but I think it's a misunderstanding of how to use and the consequences of just using the static import, right? So like I said here in the pitfalls clause of this report, when you use the import statement, you're actually telling Webpack, hey, I need this functionality in my initial bundle, right? And like I said, the web's new to us. So if you don't understand some of these finer details of your tools, you're going to end up with this, and it's super common, right? So it's not surprising to me when I go into and profile an app that I see 18 megs of JavaScript. So is the root cause maybe engineers? Like, should Webpack be documented better? I don't know. But the point is that we know that this is just probably something that's not intentional. So what did we do to fix it? Well, you learned that we can employ this technique called code splitting. So we went in and this would be one example, right? We could replace all 200 statements with functions that return a dynamic import. But that's not very convenient, right? So what if instead we created one function that based on a locale parameter and a region and a product returned a dynamic import? So you can see here, this is the dynamic code splitting that we employ. And now I've concatenated some of this code, but this is the live source code, of this application. What we do is we create this locale map, and then we call this function, right? And so whatever locale is passed in and the product, then it's going to serve up only that JavaScript bundle asynchronously. So, but Sean, what about the network times? That's like now you're waiting on a slow network. And you're right, we need to negate the network cost. So the technique that we use was service workers, right? Who uses a service worker today? Maybe a few. Now, did you know that you don't even need to have like true offline mode or anything? Like if you just want to negate the network cost, a service worker has a cache that you can preload all of these assets. So there's two amazing plugins in the Webpack ecosystem called Workbox and the offline plugin. And all you have to do is drop it in your app and it pre-caches all of the lazy loaded bundles that are created at build time, right? So this is one of the most important parts about statically generating these lazy loaded files. Because what happens is that the user, when they go to your page, in the background thread, a service worker is downloading every single lazy loaded bundle and caching it. So when the user triggers an event that's going to warrant something to be lazy loaded, there is no network cost. It's already there. So you might be like, all right, Sean, I get the technique. Did it work? What was the results? So we're going to remeasure it live, right? So we're going to open it up. We're going to inspect. This is the live production application right now, right? All right. So instead of 18.8 megs of JavaScript uncompressed, we've now reduced the size of the bundles to be 4.7 megs of JavaScript. So this is still a really large amount, and it needs to be reduced. But what's the result in terms? So that's the profiler, right? I did a profile, and we could actually still take this one, one step at a time, and we could dig in even further. But let's actually get a performance timing, right? Because this is how the user is going to perceive this page actually loading, right? So now on I think pretty decent Wi-Fi, like we'll profile this. Okay, let's hide coverage. Let's hit reload. Okay. Wow. Let's see what the profile comes up with. Come on. There we go. Okay, so now we've cut, so this red line here represents kind of the time to interactive, or it's kind of split between these two. I'd have to scroll down to see, but let's see. Oh, how do I see that again? It doesn't matter. The point being is that instead of 4.4 seconds, we've cut it in half. The load time of the application is now cut in half, which is a huge win. And it's even huger wins if you're in e-commerce or whatever. So I actually opened this up on Wi-Fi on a plane, and it worked within 3 seconds or 5 seconds. And that's like an acceptable metric that was really impactful. So, and I have the stats here, of course, right? So let's break it down. So when I did the report, here's the before and after. Now it looks like what they have now today isn't deployed because I just did this recently. So it is. They got it down to 2.8 megabytes of JavaScript. So the code waste decreased from 97% to 69%. The time to interactive on a good network was cut almost by 3. This was cut by a factor of by half, right? And most importantly, this is the 3G time. So that's super huge, and there's room for improvement still. Why should I care though, Sean? Because the future of the web is going to be mobile. It's going to be more constrained devices. One of the cool things is that people don't realize is if I'm using a Surface and I'm in not the best Wi-Fi, even a slow processor can really impact how long it takes to parse JavaScript. And the point is the less JavaScript you load on the initial download, the faster your page loads. And if that's not enough, if you don't just want altruism, here's some statistics. Sites that are loaded in 5 seconds versus 19, which is the internet average right now for mobile, 60% greater page views per visit, 35% lower bounce rates, 70% longer sessions, 25% higher viewability, better indexing. And so if you can break past these averages right here, 19 seconds, even just cut it in half, you're making huge return on investment. Web performance isn't just for fun. It's a huge business decision and return on investment. This project or this report, it took me longer to write to the report than it was to refactor this application. It took 3 hours across 2 days. So have a system, right?
It's like MIPDIA.
MIPDIA.
Use MIPDIA.
You measure, you profile, you diagnose, you
MIPDIA.
identify, and you attempt.
Oh, you're making an acronym about it.
MIPDIA. MIP.
So yeah. And you know what? Like, if we can do it at Microsoft using the same technologies that you do, React, TypeScript, Webpack, that means that you can do it too. And every since this is a feature that's based on the code you write, you don't have to configure anything. So before you go back and think like, well, I don't know anything about Webpack, you don't need to. You just have to use the dynamic import statement, and that's all Webpack uses to split code out. So thank you very much.